So we could see about getting Sun to GPL ZFS. So far, it seems like that will only happen when hell freezes over. I've been asking for years. I will keep asking, and believe me, when I say asking, I mean at the very highest levels at Sun. They hear about it from me all the time. I don't know if it will ever happen, or if it's even in Sun's best interest for it to happen. I'm just approaching the problem from my greedy point of view, where I want to run ZFS on Linux. So there are a couple different ways that can happen, and GPL and ZFS is one of them. Since it's not here, I can't bet my company on it, and we need a solution today. And BitterFS is coming. It's been committed to the Linux tree, and its stated intent is basically to replicate ZFS functionality in the Linux kernel. So the window of opportunity where GPL and ZFS may be closing, and some may know that. I just don't know. But clearly, we need to move on. With Nexenta, very exciting, I think. It sounds perfect. It really is the Solaris kernel with Linux userland. Exactly what I think we would like. And I have told Sun this, and plenty of Sun people, as we heard from the introductions, are in the room. So Sun, please listen. But we are dealing with mission-critical data that our customers are paying us millions and millions, tens of millions of dollars a year to take care of. And so the fact that Nexenta is sort of small and doesn't have the same level of support that Sun can offer me meant that with a heavy heart, I had to at least pass it by this time. So moving on, again, we get to eat sushi. I love sushi, so I was pretty thrilled when this opportunity came along. Late last year, I got an email or a phone call or something from Sun saying that they had some great new hardware that they thought would solve our problems, and that they had codenamed all the hardware pieces after sushi. And so I was thrilled. I got to combine hardware with food, and the end result is our favorite of the three. You saw all three on the slides earlier, was Toro. It's one of the S7000s. It's the 7410 configuration, which has dual quad-core Opterons and 64 gigs of RAM in an appliance head unit attached to a bunch of disks. Also in the head unit are anywhere from 1 to 6 SSDs. They call them read zealots. They're basically 100 gigs of read cache, extra cache, a layer 2 cache. In the attached storage, you can toss a bunch of write zealots, which are write-optimized SSDs. They're pretty innovative. They have some RAM in them with a supercap, so that in the event of a power outage, supercap can keep the RAM and SSD powered long enough for it to drain the SSD. So you get RAM-like write speeds to SSD, which then later flush to the hard disks. There are 22 of the hard disks in the enclosure configured like ours, where we're using 2 of the slots for write zealots. And we chose to go with a clustered HA configuration where we have 2 heads attached to a JBOD enclosure. And they, of course, monitor each other and can fail over on a head node failure. So this is a big win for us because we can finally do ZFS on Linux. Not only that, but we've been watching SSDs for quite a while and wishing that our data size was smaller so that we could just throw everything on SSD. But with thanks to Toro, we can now take all the benefits of SSD and all the benefits of big spinning media and blend them together for great performance. Luckily, Sun was thoughtful enough to provide all kinds of ways to consume all of these IOPS and terabytes. We're currently using NFS v3 after trying both NFS v3 and v4 out. I can talk about that a little bit in a later slide. We haven't yet played with iSCSI. And the other ones, CIFS, HTTP, and FTP, are interesting for some other use cases we have internally, but not for our database use case, which is the low-hanging fruit we're focused on right now. This is a big change in terms of architecture for us. We traditionally use DAS, or direct attached storage. So we have a server directly attached to a big pool of SCSI disks, which is more flexible than having the disks inside the server. Should we have the server, say a piece of RAM or CPU or something go bad, we can just slide the server out of the rack, slide a replacement in, attach the disks, and we're back in business. But it's nowhere near as flexible as this network-attached storage appliance, where we can now simply unmount and remount mounts from anywhere in any of our data centers and utilize the capacity of the storage. So the extra flexibility is turning out to be awesome. We like flexibility, especially with two ops guys. It's really handy to, if a node dies or something, just reparent without having to have any cabling or screws or anything replaced. The Fishworks interface is a dream. If you guys haven't seen it yet, I think they have some simulator or something online that's amazing, and I'm sure they'll have them somewhere here, or one of the talks will be showing the interface off. I was tempted to like pull it up and play with it a little bit in real time, but I better not, because I will get off in the weeds. And especially, I wanted to call out the analytics is just unbelievable. I'm going to talk about that in more detail in just a minute, but the analytics really is a game changer. Unlike, I thought the SSD blending was a game changer, but analytics is at least as big of a game changer, if not more. So initially we had some sticker shock. On the website we got an eval unit, which was great. Nothing better than free for a couple months. But then when they shipped, we went to go and see about buying some, and they were 80 grand a pop, listed on some.com, or 142,000 for the configuration that we want with the clustered head interfaces. So I freaked out because that's just not going to work for us. But it turns out that, like all the other products on sun.com, I have no idea why the prices are listed that way, but nobody pays for them at this price. It doesn't matter whether you go through an internal salesperson at Sun or through your favorite VAR, everybody gets a lower price, so I'm not sure why Sun scares away potential buyers. I know because I've answered emails on this subject from people who just decided not to buy based on the sticker price. But nobody pays this price, so talk to your salesperson, whoever that is. If you're lucky enough to be part of Startup Essentials, like I am, that's absolutely the best way to get yourself some S7000 love. And probably most important is the paradigm shift I talked about before. That made all the difference in our total cost of ownership math, because now we can stack a bunch of clients on a single appliance. We sort of knew how great SSD was, and in theory how great a hybrid storage pool would be, but before we actually were able to benchmark it and test it in production, we had no real clue as to just how enormous the difference was. It turns out that we can stack an awful lot more clients on each appliance, so there's nowhere near a 1-to-1 or 2-to-1 or even 3-to-1 comparison between our previous direct attached storage enclosures and a Toro. So we now have currently in production 5 cluster configs like I described earlier, and I absolutely love them, in part because they are crazy fast. So this is the eval unit we first got, which only had 1 writezilla. Our production ones have 2 writezillas, so they're even twice as fast as this is. This is not a synthetic benchmark, this is actual workload. We were intentionally trying to add more MySQL clients to the box to sort of stress test it, but actually we weren't like trying to find out its max or anything. And at this level, I just happened to notice this in analytics. It wasn't performing badly. We weren't like, looking for why it was performing badly. I hope you can see the numbers up there, but the quick summary is that we are pushing almost 10,000 IOPS through the appliance. Through this one Logzilla. These are the NFS operations per second, not just the disk write per second. So the NFS write comes in, and from that moment until the write is completed, including all the NFS processing and all that sort of stuff, 4,500 of them are occurring under 43 microseconds, and 8,000 of them are occurring under 166 microseconds. When I say crazy fast, I mean crazy fast. As you can probably imagine, once we saw this in production with our workloads, we got really excited. So in production, we are stacking MySQL clients like crazy. We have previously partitioned our database vertically into a bunch of different workloads, some read heavy and some write heavy. all the workloads are now, there are replicas from all the workloads on each clustered Toro we have. It no longer matters that I used to have to separate write-heavy workloads from read-heavy workloads so I could tune the disks or the amount of RAM or whatever. We're just shoving them all on the Toro and letting the readzilla and writezilla portions of the hybrid storage pool take care of all of that sort of optimization. I don't have to think about it anymore. That's huge. Each of our nodes used to have 30 15K SCSI disks with a gig of battery-backed RAID cache. So let's say one of these Toros has 5 clients. Many of them have more than 5, but you're talking about like the equivalent of 150, 50K, 15K SCSI disks on this one box that has 7200 RPM drives. And we still see lots of excess capacity. We're nowhere near the capacity that we've been able to sort of push it towards. As far as management is concerned, I talked about flexibility before, so it's really awesome being able to reparent the nodes that are using the NFS mounts and everything. But it's also incredibly awesome for when you need to add more capacity. Because with MySQL, spinning up a new replica of a slave usually involves taking a snapshot from some server, and remember, our snapshots can be like 2 terabytes in size, copying it over the network, then letting it catch up on replication for a few hours until it's up to date, and then putting it into production. It's just 2 clicks on a Toro. I just click snapshot, and I click clone, and now I have an entirely new version of that data that I can mount from a new server I may have just installed, and I have a new MySQL slave. It's really that simple. We're hopeful that deduping is coming in ZFS, and if so, we think that between cloning and deduping, we can get some insane efficiencies, way beyond anything we thought was possible just a few months ago. So let me take you through a quick scenario. Let's say I have a MySQL slave on a Toro, and I decide I need 9 more of them. I could just snapshot it, hit clone 9 times, and we're already not taking up any extra bytes on disk, right? Because they're clones. You guys are all used to that, and we love that too. But now imagine that future writes, instead of causing all 10 of those snapshots to diverge from each other and start chewing up lots of disk and generating lots of writes, imagine all the slaves are roughly in sync and doing the same writes, and ZFS or the appliance sees it and goes, oh yeah, we can just dedupe these. So we'll do 1 write instead of 10. Or even more importantly, maybe, when you go to read something, it doesn't have to like fragment the 64 megs of RAM or the readzilla 100 gig things, SSDs, to cache 10 different copies of the same data. The appliance is, in theory, maybe smart enough to just cache 1 copy and then the other 9 just reference that copy. So you get a 10x or even more multiple on your caching layer. This is all sort of future stuff that I'm talking to Sun about and hoping that is being worked on, but we see deduping in other appliances and stuff, so I imagine it must be coming. The other awesome thing about Toro is the analytics, which of course gets us the other piece that I would love to see on Linux, dtrace, and puts it in a really great user interface. Again, if you haven't played around with the simulator online or gotten yourself an eval unit or something like that, you really owe it to yourself to take a look, because you can get crazy, crazy, crazy amounts of data on all of your storage requirements and needs. So in the past, we used to call the storage vendor. It didn't matter if it was Sun or Dell or whoever, and say, hey, we're running into some sort of performance problem. We're trying to track it down. Can you help us? And the only answer was, well, we really don't know what's going on either, but we'll be happy to sell you some more disks. And our old answer was, yeah, okay, fine, we'll just get the credit card out and buy more disks. With analytics on the S7000, we know everything. We can see exactly which disk or which operation or which protocol is causing the bottleneck, and have a really good idea about what we can do to fix it. In fact, when we were just getting started, I would email the beta team who wanted our feedback saying, hey, we're seeing this weird anomaly. And it didn't take more than a reply or two for me to get used to the fact that Sun's first answer was always going to be, yeah, well, what does analytics say? I've been trained for the last 12 years or whatever, that the storage is too dumb to give me any info. I was just asking the vendor, Sun, for that info as a natural habit. I've gotten out of that habit. I look at analytics nonstop now, and when I do ask the storage vendor, again, in this case, Sun, actually have really hard data, and they can get me a useful answer instead of just, buy something. Or more often, I don't even need to go to Sun because I get the answer myself. It really does let you drill down and correlate just about anything, and to a sysadmin or an ops person, it sure feels like godlike power. On our implementation, MySQL on Toro, so far we've learned to use NFS v3 rather than v4. I'm not entirely clear why that is yet. That's a sort of a fairly new thing we've come to the conclusion of, and we want to find out why. I suspect that NFS v3 is just a simpler protocol, so the latency is better. It's just essentially doing reads and writes instead of some of the other more complicated things NFS v4 is doing. But it could be something else entirely. On Linux, you want to use the no-op scheduler because it's pointless to try to have the kernel optimize the writes, the ordering of the reads and writes. It's going to send to the storage when the appliance does such a great job at that already, first of all, and second of all, it's got all this new stuff, SSDs and everything, that don't really benefit necessarily from trying to do write combinations to optimize the spin of the disk and all that sort of stuff. Use the 16K record size in ZFS if you're using InnoDB. InnoDB uses 16K pages, and matching the page size to the record size seems to provide the best benefit. We use a mirrored, so essentially a RAID 1 plus 0 equivalent for our spinning media, the 7200 RPM drives, but we do stripe our Logzillas. So our Logzillas do, as I showed you, close to 10K IOPS each. Striping them gets us 20K IOPS, which is way, way more than we currently need, but it's always nice to have. MySQL is concurrency bound and just has no idea what to do with all this I/O. It wasn't written with this amount of I/O in mind, and I'm positive other, not only applications, but OS level subsystems, we're going to find out, all have just don't know what to do when they're presented with 20,000 or more write IOPS. It's just such a paradigm shift. So we do have to layer multiple clients, like I talked about before, just to utilize the machines as well as we really want to. I'm hopeful that MySQL and Sun, since they have such a vested interest in seeing this happen, will continue to get better on concurrency and will eventually be able to use lots and lots of IOPS. If you are going to compress, LZJB is your answer. One big gotcha for those of you who might be doing MySQL that we just learned on Friday, so this is a new bullet in my slide. The replication info on each slave is not properly synced to disk across NFS. This has nothing to do with the S7000 series appliances themselves, but is more likely something to do with MySQL and the Linux kernel. For whatever reason, the Linux kernel is not shuffling writes to that file to disk across the wire, so the appliance doesn't see them. So if you take a snapshot out from under it, those files will be out of date, and you'll be at an unknown replication state. There are a number of possible approaches to solve the problem. We have something in the works that we think will solve it, and a number of other MySQL problems unrelated to storage that we're going to be testing, I think, this week. So I'll be blogging about it and stuff. If this is your thing, you'll probably want to follow my blog. There are still a bunch of things we still want to look at ourselves. We haven't played around with iSCSI at all. So we probably want to, just to make sure that NFS is the best solution for us for MySQL. We care about latency a whole lot, as I already mentioned, for our writes. Now we're measuring them at microseconds. Network latency is getting to be a reasonably large component of that. So we think that 10 gig might be a way for us to shave a few microseconds off. So we are actively testing this. We have one of our Toros with 10 gig cards in it, and some clients that we're starting to play with. The best part about this that makes it really easy to try is that 10 gig hardware is finally cheap. You can get cards from Intel that are like dual-ported cards for $600 or $700. You can get great switches that are less than $500 a port. And even the cables, we found copper SFP plus cables that are well under $100, like 60, 80 bucks or whatever. So it's fairly cheap from a cost point of view to use 10 gig if it turns out that you need either lots of throughput or really low latency. But again, we haven't actually tested the latency theory yet, so I will be blogging about that. I was trying really hard to have a slide on it here, but we just haven't finished. We don't have enough data yet. One downside, though, is that the optical XFP transceivers and cables and everything are still very expensive. And right now, the S7410 only supports XFP. So you're stuck using an expensive card and expensive transceivers on that box, but all your servers that then mount the NFS mounts and stuff, if you buy your hardware right, you can use SFP and you'll save a bundle. Of course, the Toro is great for things other than MySQL. It just happens to be the thing that that is our biggest pain point, our lowest hanging fruit. But everything we've tried so far runs better on Toro. So our revision control system is fabulous, as you can imagine, and it sure makes taking backups of it and things super easy. All those stateless Linux mounts I talked about at the beginning of my talk, they can all now mount a Toro, which is much, much faster and keeps everything in cache, much better than our previous NFS solution. All of our email clustering stuff can all be kept on Toros now. We're still playing around with what the right record size is for something that small and how performant it is, but for a tiny company like us, it's a no-brainer to do, even if it's non-optimized. Our developer home directories, and of course the S7000 has built-in scheduled replication and snapshotting, so doing backups to multiple sites or data centers is a breeze for all this stuff, including MySQL. We haven't played around with it for photo and video serving yet because we do use Amazon S3 and find that it's very fast and economical, but we think that if we were to do some of it in-house, this would be our solution too. We'd probably get a whole bunch of JBODs and attach them to a single head unit, but it's something we haven't played with yet. So that is my report on why Toro is my favorite sushi. I blog about this stuff all the time, so feel free to subscribe to my blog or follow me on Twitter, catch me in the halls or whatever if you have questions that we don't answer in the next 5 minutes. But I find this stuff super exciting and would love to hear about whatever you guys might be doing with it too.